Hello everyone and welcome to today's webinar. My name is Michael Wilkinson. I'm going to be your host for today. Today we're going to be talking about digital solutions to challenges in system operations. Before we begin the presentation, I've got a few housekeeping notes, and at the bottom of your screen you're going to find some buttons that you can press that will help you to navigate through the platform. So the first one to be aware of is that all the tools are movable, and you can drag them around on your desktop as you see fit. You can expand and minimize them. One of the buttons is the questions Q&A. So if you have any questions during the webinar, then please feel free to submit them as we go along, and they will be answered by the presenters at the end of the session. Of course, a copy of today's slide deck will be available for you at the end of the webinar. That will be shared with you. And also note that there are some additional resources and materials available in the resource list, which is also one of the buttons as well. I encourage you to download any of the resources that you might find useful. And as a quick tip, if you experience any issues with the platform, just press F5 on your browser and it'll reconnect you. If you have any other help questions, then feel free to submit it as a question as well. So with that, I would like to get started and introduce you to today's presenters. As I said, my name is Michael Wilkinson. I'm our Segment Director for Energy Digitalization. And I'm pleased to say that I'm joined today by a panel of experts. First up, we have a special guest who is Svein Olsen, who is from Statnett. Svein is an enterprise information architect and also a member of many different IEC committees and convener of other committees as well. Next up, we'll have Marilee Akuri, and then we'll have Hans de Heer and Theo Gorst. So a range of presenters today who have quite some good experience to share with you. I'd like to start by introducing very briefly a little bit about DNV GL. DNV GL is a global quality assurance and risk management company. In the energy business area that we work in, which for us is power and renewables, we have about 2,000 domain experts working across the clean energy value chain. And in addition to that, we have about 1,000 people who work in our digital solutions business areas, so working across the different business areas and activities. So we work in many different industries, but actually around about 70% of our business overall is related to energy in one form or another. So aligned with our vision to be a trusted partner for global transformation, we really see that energy is one of those key transformations and the energy transition as well. Today's webinar is part of a series, and this is number 3 of 5. So if there are other topics that you're interested in, then feel free to check them out. The first and second webinars have already happened, so you can get the recordings. I understand they're in the resource box. And if you want to participate in the upcoming webinars, then you can also find links to those in the platform as well. So that's enough from an introduction. Let's take a look at our agenda for today. We're going to have 1 hour in total. We will aim for 10 minutes of Q&A at the end. So like I say, submit your questions as we go. But first up, I'd like to start with an introduction to maybe set the scene a little bit and talk about digitalization and the future of energy. So this is a very broad topic, and there's no doubt that there's a lot of hype around digitalization. But I think that what we can do here is maybe try to cut through that a little bit. You know, when I think about digitalization and what it means, I like to compartmentalize it in my mind to separate or distinguish between what I call digitization, which is maybe making things digital, And then digitalization, which is really the sort of the business opportunities that are created by that digitizing. And then finally, the next step on the journey is one of digital transformation. So to my mind, start by making things digital, adapt and change the way that your the business works, will follow from that. So digitalization is a key enabler of two key industry trends, which are really related to the heart of the energy transition. So these industry trends are decarbonisation and a decentralisation in the electricity system. So in addition to these high-level trends, it's important to say that digital technology and digitalisation is not new, of course, to the transmission and distribution industry. In fact, digital is an integral part of a current energy system, and it's really an important instrument to allow us to continue to operate our systems. The power industry, of course, has a long history of applying digital tools and also in upgrading analog systems. So this includes everything from automation of network operations, the emergence of sensors and data analytics to enable smarter asset management, and then the better utilization of some of the main system elements. The ongoing decentralization of the electricity generation structure also requires more sophisticated supervisory control and data acquisition and grid-related operation tools. So in these trends, we see that electrification, which will result in more electricity demand and more pressure on the network, is also balanced against the need for constantly reducing costs and reducing risks and increasing performance on both the short, medium, and long term. So one of the things that I was really keen on doing in my role is to help to understand what we actually mean by digitalization within the power and renewable sector specifically. So we have conducted a study. We've asked nearly 2,000 people from across the power and renewables industry. So that's the clean energy generation, transmission, distribution, energy storage as well, and energy financing, but also in energy management as well. And then we conducted 5 in-depth interviews as well. And the results were, I think, quite interesting because they tell us quite a lot about the way of thinking of the industry. First up, we saw that digitalization is clearly important. So actually 87% of respondents said that their company has a digital strategy in some form, but only 20% feel that they are leaders. When we think specifically to the distribution network operators, only 52% have digitalization as a core strategy. And then looking to transmission system operators, that drops to 39%. Only 1/3 of the transmission and distribution industry feel, 1/3 of the transmission and distribution industry feel that they're less advanced than the wider industry as a whole. So clearly some opportunities for exploiting digital technology there. We asked what people are using digital technology for, and the interesting answers were that most people are actually using it for improving efficiency, or the immediate short-term benefits are the main expectations of digitalization. So for transmission system operators, top priorities are improving operational efficiency, improved decision-making, and then cybersecurity. For DNOs, the top priorities are cost efficiency, improved decision-making, and improved operational efficiency. We asked then, what are the biggest barriers that people experience? And we saw that the answers to this question are quite interesting, because I was expecting maybe that this would be a response related to lack of access to technology. But actually, the biggest answer was highlighted as being a lack of digital mindset. And this varied across the different subsectors where we asked this question. So some parts of our industry more advanced in that. Some people reported it to be more of a barrier, and particularly within the TSO and DNO respondents, we saw that lack of digital mindset was a bigger barrier. So these human factors are crucial as well. And then finally, my final note here is we asked what are the skills that are in demand, and 71% reported that as well as specific individual digital skills, what people really need is employees with a combined data and domain knowledge. So it's this combination, the ability to understand the problem that is being solved, understand the domain, and then to deploy digital technology to solve some of those problems. There's a lot of statistics on here. Of course, all of these are explained in more detail in the report, so feel free to check that out. Search for digitalization and the future of energy. Let's summarize very briefly with how that relates to the power system. Overall, we're seeing that the transmission system and distribution system operators are really focused on getting value from data and then turning that data into action in the operations phase. A lack of digital mindset, very much common there. And then also the skills in demand, data and domain expertise, that combination. Integration of renewables is one of the key opportunities related to digital technology. So that's a little bit of a way of introduction. Now let's get into some of the details, and I'd like to hand over to some of my colleagues now who will talk through some of the work that has been happening in our industry. And first up, I'm going to introduce Svein from our external presenter, who's going to be introducing the first of all the challenges from a utility perspective. And then after that, we'll have Marilee, who will be talking about how we can address some of these challenges using common information models and common information model testing. So Svein, over to you.
Thank you, Michael. Good morning, everybody. I would like to start a little bit about telling what's the reason for doing standardization. Obviously, we want to make things work, and having expert and world-class specification on the product and the system is one of the key elements. What we also want is the standard is to help us making sure systems are interoperable, making sure that we have an efficient way of communicating between different kind of application that's dispatches through the organization or through the ecosystem of the environment you're operating in. And of course, the idea that it should be also on cost efficient. Sometimes standard will not be cost efficient in the beginning, but as people are using this in multiple projects and people get more exposed to them, the idea is that this will reduce the overall cost. Standard and the test verification is equally important. This is where the standard or the written word meets the real world. And it is important, particularly for getting the quality that the utility wants and for the vendors to get out to the market. It will be cost efficient in the way that you can do one test and that could do one verification that can then lead to the usage in multiple places. And for the utility, this will be cost efficient that they know that this test has already been, or this test has already been performed, and thereby not needing to redo it. It is important that the utility sees the need when they are requiring application to request or demand that the application has gone through some level of certification or verification. And bear in mind that being conformed to a standard is not the same as is being interoperable. Conformance is where you check the application being compliant to standard or part of the standard in an auditable environment, where we also look at both positive test and negative test. Conformance doesn't ensure that the exchange is interoperable, but it builds the building block for making it happen. So there will also be need for interoperability, and to some extent you also want to use your own data or real data, while in conformance might be just test data that everybody knows the outcome of. And the typical for interoperability is that you only have a positive test and with witnesses. So to be successful, you need to have both conformance and interoperability tests. Looking at the European interoperability framework, they are dividing the interoperability into 4 different levels. The legal perspective, which is like for the TSO and DSO in Europe, really related to the new network codes that's coming out. In US, it will be FERC and NERC type of regulation that they need to comply with. Organizational interoperability is to deal with that the flow works and the application works inside, and you have the right decision level. You make the data flow accordance to the regulation, dealing with the timing and also to some extent the linkage to technology, so technical interfaces that needs to be in line. New things that we like to emphasize is the semantic interoperability, and as a lot of time forgotten, and as we are moving to more and more complicated type of data exchange, this becomes much more important. If you're only going to exchange time series, there is not that important to have a common understanding of the semantic interoperability. However, if we're going to do a pan-European twin system, twin of the power system, the semantic understanding that the application needs to have is extremely important, and you need to make sure that you can get the same result or at least similar result between different applications. And of course, you also need to have the technology interoperability in place. Looking at a little bit the challenges that as a utility we have the legal interoperability, that how do we make sure that we are in compliance with the network code. We also need to make sure that we have the right information, the right type of requirement when we are requesting for new application. We also need to make sure that that we meet our specification, or the vendor or the tools that they have supplied. How do we ensure that they meet the test? These 2 elements in it can really easily be checked with the standard, referring to the standard, referring to the interoperability. We also need to do interoperability to make sure the application works. As everybody that has been involved in the major application changes or updates, particularly EMS or DMS type of system, we know this is extremely costly. And how can we actually get that type of cost into a reduction? And in the newer world where things are changing much more rapidly, an evergreen type of solution becomes more and more important, meaning that you are on the latest version of the application with the latest patches and the latest functionality. And also in the world of digitalization, the ownership of the data is kind of moved from the utility, from the application to the utility, thereby that the application and the data quality has been very much one and the same. And now when the data is kind of outside the application, you really need to make sure that you have the sufficient high quality or the level of quality that you need. So a little bit about the background, what Statnett has been doing. We've been a key player in the Norwegian standardization market or adaptation of the IEC SIM standard. Primarily, we're looking at the functional part, 61970, and obviously also looking at the European market, where we are involved in that. But what we're now looking more and more into is the asset management and the asset health. The SIM was a central part of the EMS replacement, and is also a central part for us in our reporting and giving the metadata needed for a lot of the sensor data that we have, a lot of the metering data. So what we're trying to do is to embrace change. And I think that's critical for industry, that we can't be reluctant to take new challenges because we are in a very changing environment. I think we'll inspire even more changes moving into the future. In that way, at Statnett, we are using multiple versions of the SIM at the same time. This is, of course, a challenge, but it also makes us move forward. So the new application can be on the latest standard, while we still have some slackers that could be on an older standard. What we also want to make sure is that we are able to pick, best of breed. That we have interoperability between the system and an evergreen. And with an evergreen, you really need to do a lot of testing. And we're also using is our standard to provide a model-driven development. And this is particularly relevant in regards to integration. So give over. Thank you.
All right, thank you, Svein. And with this, thank you for introducing the standardization, the need for standardization, and the need for the SIM standard, and the challenges that you are facing in the electricity market. So just to recap a bit, so Michael introduced the 3 trends we are currently experiencing in the energy transition and positioned the digitalization as the key enabler in solving complexity that it's required to invest, maintain, and operate the future grid. Svein, you introduced the challenges that it's facing the utilities. We see more and more participants having to exchange data, a sheer amount of data, to enable this new way of managing the system. We call it active management, active network management. And here we see that we need to exchange data, and this data needs to be standardized in order to enable this interoperability as a basis for this interoperability. And SIM IEC standard is the key to integrate the grid interoperability. However, there's a real need to build knowledge about the SIM, around the SIM standard, but also to test the standard to make sure we can use it and it's applicable for our system and for our business processes. DNV GL offer the ability for these utilities and vendors to test compliance to the standards based on the smart grid use cases and provide advisory service to support various stakeholders. So within DNV GL, we have our expertise in testing the IEC protocols and different capability in testing tools. We have developed in the past different tools that could test different part of the whole value chain of the electricity network. And our recent addition to the tools is called Symbion. Symbion will be able to test several use cases of the IEC SIM standard, IEC 61968, 61970, and 62325. Symbion will be built on a modular approach where we will be able to integrate different use cases and continuously develop the tool as well. So in order to enable this conformance testing, you have to think about 3 things. You have first to think about the SIM use cases. What are the use cases that you need to develop? first of thing, you need to develop sim use cases that can fit for all the standards. For example, IEC ISO standard, for example, to fit the IEC 61850 or the DLMS for smart meters, or even SIM and BIM. And this is why we need harmonization between these standards. We need to develop SIM use cases where you could enable the exchange of network and the exchange of data to enable this, for example, TSO and DSO coordination. But also you need to exchange messages to enable, for example, flexibility providers or energy providers to exchange data with regarding to their services. And of course, to exchange data between different systems, like common info, like the grid operation, asset management systems, and the customer information system. Second thing you need is to have the basis for this conformist testing. We need to have the roles and responsibility established. We need to have the association who's going to certify this SIM use cases, who's going to certify the tools and the testing lab. You need to have the testing lab who can provide these services, of course, and here the vendors as well and the utilities, like yourself, plays a big role in requesting this conformist testing. We need to develop the tool. The tools, as I said, needs to be modular and capable of testing so many use cases. And we need to develop the testing data and the testing script as well. In order to achieve interoperability, we can think about several use cases. So you could self-assess yourself or do FAT testing to make sure that the tool is very well tested. You could do SAT testing with the real data to ensure quality and to verify the functionality for the utility. And you could do like business processes to pre-verify flexibility provider when they are bidding for the flexibility market, for example. And how you can do that. This is the proposed way of how we can do that. We are building all this on our knowledge in protocol testing. The tool will be, of course, accredited, and the testing lab will be accredited by the certification body. The tool will be hosted on the cloud. We call it Veracity in the DNV GL, so you have access to it you can have access to it, and it's capable of running different use cases. But most important thing is that you are able to improve the standard and feed back this improvement to the standard by testing these use cases and feed them back to the working group. And we are doing this to support the digital transformation and create value for different stakeholders. We are doing this for the utilities, DRs and aggregators to enable this evergreen strategy for them to acquire interoperable systems and to be compliant with the regulation. For the vendors to reduce integration costs and increase their market share by providing tools that are conformant to the standard, but conformant to the RFP for international association, that these international standards are being deployed. For IEC and Senelec, that we are continuously using and improving the SIM standard. And of course, for us as the DNV GL, that we are an accredited SIM testing lab capable of providing this kind of services and advisory around the SIM standard. At the end of the day, we are doing this to reduce cost, reduce emission, and of course, lower the electricity prices for us, for all consumers. And with this, I would like to run one of our poll questions. And I would like you now to vote for the questions. So Mike, the poll is: how much value does conformist testing you think add to your organization? Please vote 1 if you think it doesn't add value at all, and choose from 1 to 5, 5 being the highest if you think that conformist testing add value to your organization. So we will see while you are voting. We will see what's the vote, and we'll be able to see the results right now. So please, I encourage you all to vote for this. Okay, let me see if it's ready. Okay, we shall wait a little bit. I think only 21% have voted. So if you think conformist testing and using the SIM standard and making sure that having conforming tools add value to your organization, please vote. 5 being the highest and 1 being the lowest. So I'll give it 20 more seconds, and then we can move to the results. Before I hand over back to Michael. Okay, I hope everyone has voted now. Okay, so we have 25% of the audience voted, 4.5% voted 2, no one voted 1, which is interesting, it's a good sign. 25% voted 3, 50% of the audience voted 4, and 20.5% voted 5. So that's 70% of the audience think that conformist testing will bring value to their organization. Thank you very much for voting. And with this, I will hand over back to Michael. Thank you.
Thank you, Marilee. Very interesting results there. And thank you also to Svein earlier on as well. So next up, we're going to talk about some of the options for making networks smarter. Using flexibility options, and for that we have our expert Hans de Heer. So Hans, I'll hand over to you.
Yes, thank you, Michael, and good morning, everybody. So actually, I would like to continue our small poll by raising a second question, and the second question relates to the topic that I will present shortly. And this is about DSOs. It's about distribution system operators controlling distributed energy resources, either directly or indirectly. Our question is whether DSOs, whether you think DSOs will use market-based mechanisms to control distributed energy resources for grid management purposes. So it's a long and maybe a difficult question, but I'm sure you have an opinion about this. And we're specifically looking at business as usual situations. So we're not addressing, let's say, the emergency or critical situations, but the business as usual situation. Do you expect DSOs to use market-based mechanisms to control these DERs? And if so, within which time frame do you expect this will happen? So is this the short, the medium, or the long term? Do you expect that they won't control the DERs through market-based mechanisms, but they will control them directly? Or don't you see a need to integrate DERs in grid operations? So let's see if the answers are starting to, yeah, I see quite a few have indeed provided answers already. And I will give it a few seconds more, understanding that this question may need some time to absorb it. But then I will, let's have a look at the results so far. Here we are. Well, it's interesting to see that the vast majority thinks that indeed DSOs will use DERs for grid operations using market-based mechanisms. Not on the short term, at least the majority thinks that this will happen either on a medium or long term, or it will start on a medium to long term. So that's interesting. I would like to give some further reflections on this topic. By asking this question, whether a DSO should deploy flexibility for grid management, whether there's a need and whether there's an opportunity to do so. First, we observe there's a strong regulatory push to do so. As you may have seen in the recent clean energy package, and especially the electricity market directive, clearly states that member states should incentivize DSOs to consider flexibility as an alternative to grid reinforcement. And by doing so, they should apply market-based mechanisms. So this is something that clearly points in that direction. And as you know, this directive is something that needs to be implemented by the end of this year in all member states. But we see also a technical need to deploy demand-side flexibility. And that, of course, relates to the strong growth of the distributed energy resources, like PV generation, like EV charging. And along with those DERs, we also see a strong simultaneity of the load or generation associated with these technologies. And next to that, there's also quite some uncertainty about those technologies. And we're all looking at electric or battery electric vehicles, but what will happen if in the long term it turns out to be a hydrogen electric vehicle? That will have an impact on the grid as well, and also on grid investments. So apart from those needs, we see also opportunities to deploy flexibility. Those new DER technologies often have inherent cheap flexibility. So controlling the charging of electric vehicle is quite cheap, you could say, because for the vehicle or its driver, it may not be that important at what specific time the charging occurs. Also, technological developments like IoT also increase the opportunity, because many of those technologies are already online and can already be controlled remotely without additional upfront costs. And that provides also DSOs with the option value of flexibility, and so the possibility to delay a grid reinforcement with the notion that in 1 or 2 or maybe 5 years' time, there's a better view on the reinforcement that is needed if you move to a reinforcement finally. So those benefits are merely, I would say, on efficiency. It's about improving efficiency of grid management. But there's also an environmental benefit and environmental opportunity, as obviously using flexibility has a lower carbon footprint than a grid reinforcement. Also looking at the poll result, I think the majority indeed thinks that the DSOs will move in this direction, but that is easier said than done because it's quite complex. Of course, we see that DSOs are already have already started the trend of digitalization. They have already moved away from the fit and forget strategy, moving towards, for example, grid monitoring. But really involving the demand side, so really relying on customers and market parties to manage the grid is quite a big step, and also has quite some impact on your organization, your processes, and your IT. So here are some of the challenges that are associated with implementing DSO congestion management. First, there's the question on product design. So what is actually needed by the DSO? What kind of flexibility at what point in time? Of course, the question is also what can be provided by the market, against which price. The question how to standardize across the DSOs. Do all the DSOs need to reinvent the wheel, or is there a possibility to cooperate and to standardize together? There's the topic of market coordination, because the DSO is not the only party that wants to use this flexibility. So there's interaction with the TSO needed. There's also the relation to wholesale markets that has to be taken into account. And we see a lot of activity around flexibility platforms. So that is also what type of platform do you need, how to design such a platform. Still open questions. And of course, already mentioned, there's the regulatory context. We think it's also important to understand how those flexibility mechanisms relate to grid tariff design. How do you decide when to use such a mechanism? So how do you compare flexibility against the grid reinforcement? And who are those parties in the end that can deliver this service? Well, to not only address and raise questions, but also trying to address those. DNV GL has been participating already for 5 years in a foundation called USEF, the Universal Smart Energy Framework, where we developed, together with many partners internationally, what we consider a blueprint for flexibility markets. So it's a blueprint for using demand-side flexibility in all markets, but I would say special focus has been paid to DSO congestion management mechanisms, where we have developed a standardized approach, looking at the different roles and responsibilities, and you see those main roles in the middle of this slide. We have been discussing, but also formulating the market coordination mechanisms and the already mentioned product design. And this has led to, I would say, a standardization of how those market players should interact, both on process level, but also on information exchange level. So we have developed the user flexibility trading protocol, which is especially focusing at the interaction between the DSO and the flexibility provider. My final slide shows an example of the work we did, because this was not just a theoretical exercise. We also have run many trials using this framework. Many of those have been performed in the Netherlands, but we have now also started a trial in Scotland based on the USEF principles. It's called the Fusion Project. It's an NIC, so Network Innovation Competition project running from 2 years ago until 2023. Trialing DSO congestion management in the local area, where an important benefit of such a standardized approach is that market parties, aggregators, flexibility providers can use the same mechanism. You don't have to implement different IT systems when working together with different DSOs. But also in the end, we think for DSOs, it will bring many benefits, especially on cost efficiency. An initial assessment has already shown that this framework also has a strong fit with the GB market design. So in that sense, it's not dependent on a specific member state regulatory framework. It will be further tested in the trials, the actual trials that will start next year. And you can find further information on the Fusion project, but also on the USEF Foundation in the links provided on this page. So this ends my presentation, and I hand over back to Michael.
Great, thank you very much, Hans. Really nice examples there. So we'll move to our next example, which is from Theo Borst, who's going to tell us about some solutions using digital twins. So Theo, off to you.
Thank you, Michael. My name is Theo Borst. And also in my part of the presentation, as I'm going to talk about digital twins and asset management, I would like to start with a very quick poll question about that. I'd like to give not too much time in answering this, but just very quickly, do you think digital twins will play an important role in asset management in the next 2 to 5 years? And if so, to solve what challenges? So while I read the questions, please go ahead and vote. You can answer, no, I don't think digital twins are relevant in asset management at all. Or maybe digital twins become relevant, but it will not be earlier than 5 years from now. But you could also answer, yes, I think digital twins will soon become relevant for increasing asset performance. Or you can answer, yes, I think digital twins will soon become relevant for monitoring asset health. Or you could answer, I don't know. I'm going to wait for like 10 seconds. So maybe if you could all cast your vote before I will go to the answer page of this poll. And I think maybe we will have shortly some first indication what the audience thinks. So I'll just go and click ahead. So there we have our answers. Well, it's nice to see that the majority of the audience does see the relevance of digital twins, even before I explained what they may be and what they can mean to asset management. So when we go on, I would like to first start by explaining a little bit that grid operators and utilities are impacted by major external and internal challenges. One of which is, of course, the energy transition, which aims to reduce carbon emissions, introduction of renewables, increasing electrification, new regulations, and aging assets. Other challenges are a lack of resources, both financially and people resources with the right capabilities, expertise, and knowledge. All these challenges require asset managers to deal with uncertainties and still make the best possible decisions. Choices need to take into account 3 aspects listed here. Lifecycle costs, they need to be quantified. Lifecycle performance, an optimum needs to be selected there. And the risk of the grid, and that needs to be made in a controlled way. So clear goals are to reduce as possible, of course, unplanned outages that may affect customers. But solutions are not quickly, because there's often long lead times for grid enforcement and replacement projects. So that defines a little bit the life of the asset manager. So as we've heard earlier in this webinar, digitalization is one of the major trends in the energy industry, and it will help the transition from the traditional way of managing assets, which used to be based on reactive maintenance and periodic replacements, towards a more modern, advanced asset management practice, which is much more preventative, proactive, risk-driven, and aims to reduce costs and risks. Some aspects that are changing in this process are the shift from focusing on running the business of today to the forecasting the future and the optimization of decision-making processes. And a shift from experience-based decision-making, subjective and inconsistent, towards a much more real-time insight in condition and performance. A shift from fragmented data, data quality issues, and various formats towards the use of available datasets to create useful information. And a shift from long plan, do, check, act cycles towards a much more direct feedback and use of real-time decision support tools. So that's where we think digital tools and digital twins can come in. So how do we apply them in asset management? Digital twin is basically a representation of a physical asset in the digital world. And they can offer a versatile and flexible way to monitor operational performance and predict asset health. The Grid Analytics KPI Connect platform is DNV GL's data-driven digital twin application, which allows the ingest of relevant asset data from various sources and allows utilities to monitor and detect anomalies. It allows basically the asset manager to close the loop towards their assets. So how does this look in practice? Suppose an asset manager in a grid operating company wants to monitor and predict the asset health of their portfolio of high-performance transformers, high-power transformers. And they need to understand whether they need to be replaced or refurbished. What they would do is they would use sensor data to collect the data from the transformer, and they would ingest them and store them. And that's the nice thing, that we now have these cloud platforms available that you can use for the storage of this data and create your digital twin. So then we can use digital twin techniques to detect anomalies and predict failures and visualize that data on a nice dashboard. And then based on that insights, the asset manager can take corrective actions well before alarm limits are reached and decide, for instance, to replace or refurbish the transformer, and in that way have the real-world impact. So this is what we did for one of our customers, E.ON, a DSO company in Germany, where we have made a first version of a digital twin platform, where we have ingested data from 130 power transformers and modeled them and made them visual on this platform. And you can see both the assets on the map and the time series data from the sensor data of the transformers. And we did this by using our Veracity platform, which is a cloud-based data platform, acting as a key enabler for unlocking value of data in such applications. And many companies are working already on this platform, sharing data and creating new opportunities. If you want to know more about how we've done this, please contact us. That's for my part of the presentation. Thank you.
Wonderful. Thank you very much, Theo. So thank you to all of our presenters as well. And we'll move to our Q&A. So thank you to those who've already submitted questions into the Q&A. If you'd like to do so, you can also still submit them now. And if we don't get to them in the session over the next 7 minutes, we'll make sure that somebody is able to follow up with you. So first up, I'm going to ask a question for Svein and Mary. I wanted to take this question from Amir, who's saying, how do you think that the industry will reconcile the dissonance between, on one hand, the requirement for innovative solutions for digitalization of the grid, and on the other hand, the standardization? So Svein, maybe you want to go first. You've been heavily involved in standardization. How do you think that that we reconcile between innovation and standardization?
Yeah, you will always have some front runner that needs to kind of play the land. What is important is that type of learning get brought back to the standardization organization, either to the vendor or by the utility. Where we at Statnett, where we have decided on, because we have a bit of best of breed, so we need a lot of tools that is complying to the standard. We've been involved in the standard development, so we brought and said, you know, this is how we're going to do it, and then looking at what the next version of the standard might be. There is some risk for the vendor to implement it, but for them, our experience is that is a less risk.
Yeah, great. Thank you. And Marilee, do you have anything to add on that?
Yeah, just to add is also we have, like what Svein said, you have the forerunners who are already creating, let's say for the SIM standard, are creating already profiles or creating things that could be reused, added to the standard to improve the standard. So at least what we could do is we could test them, make sure that they're okay, and then feed this back to the working group to make sure this could be added to the standard so everyone could reuse it as well.
Great. Okay, thank you both. The next question I have is on A&M, and Hans, I think this might be one for you. So do you see A&M is just for control between transmission and distribution, or do you see other opportunities there?
Yeah, it's a bit depending, of course, how you define the A&M. I particularly know it's from the GB context, and there I think it is slowly being replaced by more market-based mechanisms. I also see a question, maybe it's related to that, on the DERMS, the role of the distributed energy resource management systems. Again, a bit on terminology, but I consider that something as a kind of extension to the SCADA DMS systems from the DSOs. And those systems, I would think, are primarily used in emergency situations. So there, the DSO has, of course, also the legal possibility to control those assets directly, if he has the technical capabilities, of course. But for the business as usual situation, so normally he would like to avoid using the DERMS as much as possible, and also A&M. I think he will move more and more towards market-based solutions where flexibility will be activated based on contractual relationships through market parties with end users rather than by direct control.
Yeah. Okay, great. Then maybe another question for you, Hans, is you touched on this a little bit in your presentation, I think, but maybe you can expand on the cost effectiveness of flexibility. So the question here is flexibility a cost effective alternative to grid expansions? What's your take on that?
Yeah, I think that is the big question, and that is, well, typically not answered yet, but I would say it's very strongly depending on the situation. So it's not a simple yes or no. I think there will be circumstances where it certainly will be cost effective, and there will be circumstances where it will not be cost effective, and grid reinforcement will be the logical alternative there. I think the most interesting opportunities on the short term is to look at situations where you have N-1 compliancy, and then you can use flexibility to basically fulfill those N-1 requirements, which as a consequence means that you will only activate that flexibility when there is a fault in your system. So very rarely. So you only pay for availability of flexibility, and then we see that there is many occasions it's indeed a cost efficient alternative to a grid reinforcement.
Okay, great. Thank you, Hans. And then maybe our final question in the last couple of minutes for Theo. Theo, the question here is: how does your definition of how does your asset management definition of a digital twin relate to other digital twins? Maybe you can expand on your definitions there.
Sure. Digital twins is a widely commonly used term in many cases across the energy, even wider than the energy industry, and it can mean different things to many people. We are taking a very much a data-centric view on digital twins. So we think data is important. Data is has inherent value that can be unlocked by using a digital twin. Others also use digital twins much more as a visual tool, where, for instance, a visualization of an asset is created just to understand maybe the construction, how it's constructed, or how the asset is built up. So there's many different ways of building digital twins. We take very much a data-driven view of digital twins.
Mm-hmm. Great. Okay, good stuff. Thank you, Theo. And it's worth saying as well that in DNV GL we have some papers where we've talked about the maturity of digital twins. So if you search for digital twin maturity DNV GL, then you'll be able to find that. I think that's all the time that we have for our questions today. So all that remains really is for me to thank our presenters. So thank you to everybody who's participated today, and thank you to our presenters. And I look forward to seeing you again in our next webinar. until then, thank you and goodbye.